In this video, we're going to talk about electrical resistance and the concept of resistor color code, including Ohm's law. So this is a lot going to be about resistance and the three forces within electricity. Electrical resistance is the ability of the material to resist the flow of electrons. Okay? We think of this as friction. So as something moves across a table surface, there's a force that is resisting that movement. We refer to, again, when we talk about movement, as friction. So if you want to think about it that way, it's the friction of electrons flowing across the conductor. Okay? We measure this in a unit called an ohm, which is sometimes symbolized with the omega symbol from the Greek alphabet. The amount of charge that flows through a circuit will depend on a few things. Okay? The voltage provided by the source, and the electrical resistance within the circuit itself. This actually, when we'll talk about it later on in the presentation, gives us Ohm's law. So we have two things we can control: how much we push, how much voltage, and how much we resist what's in the circuit that provides electrical resistance. And our result is amps, or how much current that flows. And that is a relationship that we can predict and actually figure out with math. So when we talk about resistors in a circuit do several very important things. They reduce or restrict the flow of current, meaning if another component, an IC chip, an LED, something else, needs a certain amount of current to function, but there's a different amount of voltage available, we'll sometimes use resistors to make sure that the proper amount of current is going to those components. Sometimes we need to adjust the signal level and divide and separate voltage. These are all different reasons we would use a resistor. They're going to get kind of complicated, and most people try to start to understand these concepts as they work with resistors and work within circuits. So if these seem a little out there right now, don't worry, you are not alone. One of the things we want to talk about now is measuring resistors. So when you see a resistor, they're actually quite small, but they'll have two wires and a kind of peanut-shaped body to them. Around that peanut-shaped body will be colored bands. Now, one of the things that you will have to do as you want to decide see how much resistance is actually in that particular resistor, because these are quite small, so they can't print the number on them. So that's why they use these colored bands, is you'll have to find what's called the tolerance band. It's hard to see in this diagram, but it's usually a little further away. The other three bands are usually closer together. And this is usually a shiny color. Usually, for most of what we're going to use, they should be gold in color. You may occasionally come across one that's silver. Okay, that's the tolerance, or how accurate the resistor is to the actual measurement. And then what we do is we actually read this using the chart. So each of the colors in a position means a certain number. Okay, so resistors have the colored bands that you are able to determine the number of ohms per band, and it can have a different number of colored bands. For most of the course, we're going to be using 4-band resistors. Maybe occasionally you might see a 5-band resistor. So this is how you do it. You don't need to memorize the resistance and the colors. Okay? Whenever we do problems like this, whether they're on Schoology quizzes or assignments or in class, we will have charts available so that you don't have to actually memorize it. Because if you were to do this for a job, number one, you might get to the point where you knew which ones you needed that you used quite frequently and what their color code is. Or the other thing is, you would be able to look up or have a chart that tells you this. You do, however, need to know how to read one, because that won't always be shown to you. This is an example of a color code chart. What it is we look at the first band of the resistor, and based on what color it is, that gets a certain number value. The nice part is the second band, it is the same scale. Okay, so if it was 2 brown bands, it would be 11. Okay, because again, these 2 bands form a 2-digit number. You don't add them, you don't multiply them, you don't do anything with these. Okay, If we had a brown red, it would be 1, 2, or 12. Okay, you might wonder, how do we get single digits? Single digit ones will start with a black band. So a black yellow would be 0, 4. And then we get into the third band, which is called, excuse me, which is called the multiplier. Because as you might imagine, we can't do a whole lot with two-digit numbers. We have to then multiply it by something. So if we wanted to get 200, I would have a red, and then a black, which gives me 20, and then a brown, because 20 times 10 is 200. That is exactly how you read the resistor color code. Here's another example. So the first number here is red. When I come over here, red in the first position is 2. So my first number is 2. Now this we might debate as to whether it is violet or blue, but based on the previous picture, I'm going to go ahead and call this violet, and that gives it a 7. So 2, 7 gives me 27. Yellow in the third position gives me times 10 k ohms or 10 kiloohms. Remember, all electrical units are metric units. So 27 times 10 would be 270 kiloohms. So 270 k ohms. If this was a question on a quiz, the correct answer would be 270 kiloohms or 270 K. You'll have more practice with that another time. Right now I want to talk to you about a very important concept called Ohm's law. Whenever we talk about electricity, we have to talk about Ohm's law. The nice part about Ohm's law is that we have a fairly direct relationship here. Okay? The current in a circuit is directly proportional to a voltage across the circuit. So this is a way to say how much flows in a circuit is directly proportional to how hard we push. Meaning if we push harder, more current flows. So as one goes up, the other goes up. That's what directly proportional means. The current in a circuit is inversely proportional to the resistance of the circuit. This also makes sense. As the resistance goes up, the amount of current that's able to flow goes down. From a previous video, we had the example of water flowing through pipes from a water tank. If you want to think about resistance as how big the pipe is around, if we increase the resistance by making the pipe smaller, less water will flow through. Okay? And it's because of this direct and inverse proportionality that we come up with Ohm's law, or basically that our current that flows is equal to the voltage divided by the resistance, or I. And when you're wondering why do they use I to symbolize current, I don't know. It just is. I symbolizes current. You'll just have to memorize that. Or I equals V divided by R. Now, for those of you not familiar with algebra, that means we also have a lot of other relationships here. So if I is equal to V divided by R, using algebra, we can come up with these two other equations, meaning that voltage is the current multiplied by the resistance. Or to find the resistance in a circuit, we can measure the voltage, measure the current, and divide voltage by current. The one thing to know when you use any of these formulas, though, is that when we use our numbers, we have to reduce or increase them to remove the metric modifiers. Metric modifiers are concepts like kilo or milli. Okay? So if I have milliamps, if I have 100 milliamps, I can't put the number 100 here. I have to reduce that because 100 milliamps is the same as 0.1 amps. So I have to use the 0.1 here. As another example, if my resistance is 10 k ohms, that's 10,000 ohms. I have to use the 10,000 number here not 10. Again, you have to remove the modifiers before you use any of these. Here's an example. How much current flows across a 1000 ohm resistor when 1.5 volts are impressed across it? Now what I would have to do is do voltage divided by resistance, and that would give me the current. So since I have 3 decimal places here, I would move this 3 decimal places, and I would get 0.0015 amps, or 1.5 milliamps. And that ends our video. Following this, you should have a quiz or an activity that helps you to practice both reading resistor color code and applying Ohm's law on some simple problems.